Assalamualaikum. My name is Muhammad Ashraf bin Muhammad Hanif. My matric number is B0319101195. Today I would like to make a presentation about for our assignment 1, which is we are choosing the selection sort algorithm. So let me start in introduction part. Okay, what is selection sort? Selection sort is a simple sorting algorithm. Selection sort is an algorithm that selects the smallest element from unsorted list in each iteration and places that element at the beginning of the unsorted list. So this is how selection sort works. First, start with scanning the first element with another element. Then compare the first element with all the elements for the smallest data. Swap smallest data with data at the first location. Then continue scan and swap operation until perform the correct order. So there is example of unsorted element which is 70, 50, 65, 55, 22 and 7. So we need to do a selection sort to sorting the element in correct order, which is the ascending order. So first element is 70. So 70 need to compare with 40, 65, 52, 22 and 7. So they need to searching for the smallest element, which is 7. Then 70 need to swap the place with 7. So now 7 become the first element and 70 become the last element. So for the second step is we need to start comparing second element, which is 40, and comparing with other element in the unsorted list, which is we can find that 22 is smallest than 40. So we need to change the place between 40 and 22 now until we get the correct order, which is 7, 22, 40, 55, 65 and 70. Alright, this is the example of the selection sort in real life. So we need to sorting the person who is going according to their height. So there is a 4 person, which is Ali, Amin, Aman and Zaki. So the first person is Ali. Ali become the first person. So Ali need to compare himself with other person, which is Amin, Aman and Zaki. So when Ali make a comparing or make a comparison, so they find that Zaki is the shortest than Ali. So Ali need to change his place with Zaki. Now Zaki become the first person and Ali become the last person. After that, we move to the second person, which is Amin. So Amin need to find in the queuing, which is who is the shortest than Amin. So Amin find that Ali is the shortest comparing to himself. So Amin change his place with Ali. Now the queuing is on a right order, which is according to their height. Zaki is the shortest and second is Ali, then Aman and Amin. So which is we are already successful sorted using selection sort. So that's all from me, madam. Thank you. Assalamualaikum.
Assalamualaikum and hi. My name is Nurkairunisa binti Idrus with matric number B0319100319. Today I will be presenting the picture diagram for the selection sort. First, we need to know that selection sort always start from the left. It will always set the left element as the minimum number, and then we will compare the left element with the right element. If the right element is smaller than the left element, swapping will happen. Okay, here is the example of element that we have. In this example, we will set first the left element as the minimum. In this case, 50 is the left element, so it will become the minimum value. And then we will check the right element if we have the value that's smaller than 15. In this case, 2, 42, 60, 10 and 1 is the right element. In this case, 1 is the smallest element. Since 1 is smaller than 50, swapping will happen. 1 and 50 will swap their place. After the first step, the elements still not sorted in the ascending array. So we will proceed with step 2. But during the step 2, we will set the second element as the minimum. In this case, number 2 is the second element. And then we will check if the right element has a value that's smaller than number 2. We will check if 42, 16, 10, and 50 is smaller than 2. Since none of the right element is smaller than 2, no swapping will happen. The element order will remain unchanged. And then we will proceed to step 3. Step 3 will start with the third element. In this case, our third element is 42. We will check the right element, which is 16, 10, and 50, if there is any value that's smaller than 42. In this case, 10 is smaller than 42. Since 10 is smaller, 10 and 42 will swap their place. After swapping the place, we can see that the element already sorted in the according way. So the step will stop here. So the selection sort will stop here because our elements already sorted in the right way. That's all from me. Thank you.
My name is Nafika Bitaraman. I am from BITS S1G2. My metric number is B0319101010. I'm going to show the algorithm for selection sort and also the coding. So right side here, this is the algorithm for selection sort, and the left side here is the coding. So here we have an array with size of 10, and then this is the line to display given array. So for selection sort, we need a for loop, and initialize the index equal to 0. Index is smaller than the number of paths, which is 10 minus 1, size minus 1, and I plus plus. And then we need to set the minimum with the current index. After that, we need another for loop so that we can check which element is going to be the minimum. So j is equal to I plus 1 because we need to compare with the next element. So j is less than the size of the array and j plus plus. After that, inside this for loop, we need if condition so that we can check and decide whether the current element is smaller or not with the minimum. So current element smaller than minimum. So if this is true, then minimum equal to j. Set the minimum with the current index. After that, after we decide which one is going to be the minimum, we need to swap the element. Don't forget to declare the variables. And after we have done the selection sort, we need to display the sorted array. We just copy from here and paste down here and edit some. And that's all for the selection sort. So let's run this coding and see whether the array is sorted correctly or not. Let's see here that the array is sorted ascending order and correct. So this is how the selection sort algorithm works in coding. Thank you.
Assalamualaikum. My name is Amirul Zaki bin Azlan Raus. I am from BITS. My metric ID is B0319101250. Okay, today I would like to present our assignment 1, brute force algorithm. For this assignment 1, we choose the title selection sort algorithm. For this presentation, I will cover the complexity and propose another algorithm. First, we're going to discuss the complexity of the selection sort algorithm. here, how long does it take? How many times to swap the data? How many times to swap the data in the algorithm is equal to n minus 1. What is n? N is the number of element, the number of data we input, and we minus it 1. Why minus 1? Because the last element does not need to swap. Next, we have how many times to find minimum value of data. So it is also the same, n minus 1. Next, we got how long does it take to find the minimum value of data. So this is the first, for the first iteration or loop, it will n minus 1, and the second loop it will plus n minus 2 plus n minus 3 plus and so on, and finally plus 1. Next, we are going to talk about the time complexity of the selection sort algorithm. Here we can see the calculation for the complexity n minus 1, so on until plus 1. Hence, we can conclude that n times n minus 1 divided by 2 is equivalent to this. And then next, we will remove the constant, means that we will remove the number 1, we'll remove the number 2, and then we can get the on square. This is the BO notation, the time complexity for the selection sort algorithm. Next is the priori analysis. So the first one is the worst case complexity, on square. So what is the worst case complexity? Worst case complexity means that the data in array, we got, for example, you got 3 elements, then all the data is sort descending. Means that the first big data is at the front and the smallest data at the last element, at the last index of the array. So that is the means of worst case complexity, on square. Next, we got the average case complexity. What is the average case? It means that it's in the middle between the worst case and the best case, so we can get the average case complexity. The average case complexity is the same, on square. And finally, we got the best case complexity. The best case complexity is on square. It's also the same. Why also the same? Because array already sorted, but there are 2 loops, meaning that for this selection sort algorithm, we got 2 loops, the outer loop and the inner loop. The inner loop is for looping to find the minimum value of data, while for the outer loop is to swap the data. So no matter what, how many the data you got, how many element, it is still the same, on square. Next, we are going to propose another algorithm, and that is bubble sort algorithm. So first, we're going to compare the basic for selection sort and the bubble sort. So for the selection sort, the smallest element is selected and swapped with the first element. For the bubble sort, adjacent element is compared and swapped. So for example, for selection sort, first smallest element is selected, so we're going to scan, find the smallest, and then we conclude that 1 is the smallest, and then we swap with the first element, swap with number 6, so number 6 will go to the number 1 place. That is for the selection sort. Next is the bubble sort. So the adjacent elements means that the element next to it is compared, so we compare 54 and 23, so we can conclude that the 54 is much bigger than the number 23, so it will swap. 23 go to the first and 54 go to the second position. So now we know the basic concept for the each sorting algorithm. Next, we're going to compare the base case time complexity. for the selection sort, the base case time complexity is O(n) square, and the O(n) square is also the same for the average case time and the worst case time complexity for selection sort. Next, we got bubble sort. The base case time complexity for bubble sort is O(n), while for the worst case complexity for bubble sort is O(n) square. Here we can see the difference between the selection sort and bubble sort. For the base case time complexity, for the selection sort use the O(n) square, for the bubble sort is O(n). So below here we can see the line chart for the big O notation. So we can see the, for example, selection sort use the O(n) square. So this red line, we can see how many. It depends, if the more data input, the more time taken to process the algorithm. Now we compare with the O(n), the blue color one. We can see that it takes less time to complete the algorithm compared to the selection sort. So we can conclude that the bubble sort is much better compared to selection sort. And then we got the next is the final comparison. We're going to compare the stability of selection sort and bubble sort. So for the selection sort, the stability is no, means that the selection sort is not that stable compared to the bubble sort, and bubble sort is much more stable compared to the selection sort. So why the selection sort is not stable? Because the elements which are equal might be rearranged in the final sort order relative to one another. Okay, that's all for today. Thank you very much.